We're now going to actually graph piecewise functions, and this is going to be a test in patience, so attention to detail will be extremely important. So the main goal today is to graph piecewise functions. We're only going to be graphing functions that have 2 pieces or 3 pieces. As we've seen, functions can have as many pieces as we like. Our graphing functions, though, for this particular class will focus on 2 and 3 functions. So what we need to remember is x equals 6 a solution to x is less than or equal to negative 6? Yeah, because negative 6 is negative 4? Yes, because negative 6 is less than negative 4. That concept, that idea is going to be extremely important. Second thing, substitution. If x equals 3x minus 12, we are going to be substituting values into functions find y. 3 times 5 minus 12, or 15 minus 12, or 3. That's great. What we could do, and what we will be doing when we write this is my x coordinate, this is my y coordinate, it's 5, 3. This is possibly the most important idea that we're going to focus on for function, recognizing that ordered pairs are always written with your x coordinate first and your y coordinate. Also something that's extremely important. Alright, so let's take a look at our first piecewise function. This is a 2-piece piecewise function. And in this 2-piece piecewise function, we have y equals x minus 1, x is less than 2. Y is equal to negative 2x minus 4, when x is greater than or equal to 2. So the major focus in a problem like this is you're going to want to create, you're basically going to be checking 2 values of x in each piece of the function. And it's going to be a matter of which 2 values of x you pick. The easiest way to organize this is with a table. You want to create one table to represent the first piecewise function. Y is 1 when x is 2. Now, what value do I want to pick for x? And graph 2, 0, 2, and we are going to create a table of values here, x and y. And our first primary job is to pick x value. You will always pick second, another one, but it has to be a solution. So I can't pick 3 or 4, 5 or 6. I have to pick a number that matches my graph. The key is going to be the number closest to your end. And the left, 1. I'm going to, that's not a rule, that's not a method. That's just going to make your life easier. It's going to ensure that our graphs are good. Now it's a matter of plugging these x values into the function. So my y is going to be equal to here, 2 minus 1. So when x is 2, my y is 1. Here, it's going to equal 1 minus 1. I have 2 ordered pairs. The next major how when it's an endpoint, like 2 is my endpoint. 2, 1, I'm going to circle. Circle. Because it will if the is not inequality, then you're always going to plot it as a point, and you are going to start and draw your line through with an arrow. Meaning, open circle at 2, 1, 0. I'm going to start on my line with an arrow. I will never go the other way, because this is left. Okay? Is only to go left. I'm done with this. For my second, my piecewise function, something similar. I have y is equal to negative x minus 4. And I am so long as x greater than or equal to 2. In this case, on my number line, a 0 and a 2, I would have graphed it with a closed. Really important. Really important. Because I come up with my table of values to graph this function, 2 is the number in inequality. That's the only number I have to choose. The next one, I get to pick. It has to be a solution. Because one's not a solution. Plugging these numbers into my new function, negative 2 times x minus 4. X is 2. Negative 2 times 2 minus 4, I get negative 8. I'm going to plug that. That's the end point with a closed circle. I will start there. I'll go to 3. 3 is not in my inequality, so it's a closed circle. But it's not in my inequality, so I don't stop there. And I'm going to draw an arrow through that point. That point is at negative 2 times 3 minus 4. That's negative 6 minus 4, negative 10. So at 2, negative 8, 2 on my x, negative 8 on my y, I'm plotting a closed circle. I will be starting my new line here. At 3, negative 10, 3, negative 10, I'm plotting a closed circle. Start at your endpoint from your inequality, 2. Go through your other endpoint and put an arrow. That's my piecewise function. Okay, let's flip to the next page and let's try another one. Go ahead and try to set up your tables and decide what numbers you're going to use and then unpause. So as I check here, for my first function, y equals negative 3, as long as x is equal to negative 4, I'm definitely using negative 4, and then I choose negative 5. Negative 4 is going to be a closed circle. Negative 5 is going to be a closed circle on my line. For my second function, y equals negative x is greater than negative 4. Negative 4, and then negative 3. That's the next number that we see in solid. Negative 4 will be open circle. Will be closed circle. The nice thing about this function is no matter what, I don't have to set x. My y is negative 4. As long as I have an x. My y. As long as I have an x, my y is negative 3. Negative 4, negative 3, closed circle. Negative 5, negative 3, closed circle. With we'll graph this line all the way through with 0. Okay. For the second piece, y is equal to negative x. So when I substitute in here, I have negative x. I put negative 4 in. The opposite of negative 4 is positive 4. I put negative 3 in. The opposite of negative 3 is Graphing this function is ordered pairs. -4, 4 with an open circle. -4, -3, closed circle. Start at -4, go through -3, followed by the same line all the way through, put an arrow on it. There's my piecewise function. The last one has 3 pieces, and this one's a little bit trickier. And so I'm going to get it started with you quickly. We have y equals 7 when x is less than or equal to -2. So in my table, I have to pick -2. If you don't want to draw out your number line here and check, you have a number line right here. Less than or equal to -2 means I have to pick -2. The next one to the left is -3. So that's the next number on the left. It's going to be a closed circle at -2 because it's -3 is not in here, so closed circle, graphing. My y is 7. Constant function. So -2, 7, closed circle, closed circle, graph my line all the way through and stop. Here's the one that's different. The one that actually go up, but it's not telling you exactly what numbers to put. You don't have to. When you are given 2 in your inequality, you have to use both. So the function y equals x plus 2, I don't have to worry about anything else. I just have to worry about my table. Because it's between -2 and 5, I have to choose -2, I have to choose 5. Now, what type of circle? -2 is next to less than no line under it. That's an open circle. 5 is next to less than no line under it. That's an open circle. Since both numbers are in an inequality, I am not drawing my line through them. I will start at one of them, draw to the other, and stop and connect the dot. I still find y the same way. -2 plus 2 is 0. -2, 0 is an open circle. -2, 0, open circle. And then I find 5. X plus 2, 5 plus 2, that's 7. 5, 7 is an open circle. Since those are endpoints, they're like walls, I can't go through them. Connect the dots and stop. There's my second piece. The third piece is done just like the previous ones. I have y equals 2x minus 3. X is greater than or equal to 5. So I have to choose 5 and then greater than 5. This would be closed circle, so 5. Plugging in my values, I put 5 in, I get 10 minus 3 is 7. That's a closed circle. 12 minus 3 is 9. It's not in my inequality, so it's a closed circle, and I'll goes through it. 5, 7 winds up in a closed circle. 6 and 9 closed circle. I don't stop this time. I go through and put an arrow. We're going to do a lot of these in class. These are very tricky. The key is understanding. Open or close circles. Do I draw or connect the dots? Those are the major things that we have to focus on. Practice. Be ready to focus and practice problem possible.